In section 11.5, we'll talk about the test of independence and the test for homogeneity. The test for independence can be used to test the independence of two variables. On the other hand, the test of homogeneity can be used to test whether two different populations have the same distribution. That is, do the different populations have the same proportion of some characteristic? A hint that we'll be using the test for independence or homogeneity is that we'll often be using contingency tables to display the data. There are some requirements for the test. The data must be obtained from a random sample, and the expected values in each cell must be at least 5. The hypotheses for the test of independence will be H0 will say variable 1 and variable 2 are independent, and the null will say that they are dependent. In the test for homogeneity, the null hypothesis will say that the two populations have the same distribution. That is, they have the same proportions of some characteristic. Then the alternative will say that the distributions are not the same, which will mean that the proportions of some characteristics is not the same. We will say that the random variable follows chi-squared of the degrees of freedom. And how we calculate those degrees of freedom for this test is that you'll take the number of columns and subtract 1, and then multiply it by the number of rows, subtract 1. But the steps will stay pretty much the same. We'll state the hypotheses, we'll find the critical value, we'll be using chi-squares, so this is always right tail. Excuse me. Then we'll find the expected value in each cell in the contingency table. The expected value is going to be the row sum. You'll multiply that by the column sum and divide by the total number surveyed. The chi-squared test statistic will come down to, again, the sum of the difference in the observed minus expected values squared, and comparing that to the expected values. We'll make a decision and summarize the results using complete sentences. So this can be a lot of work, and we're definitely going to employ our calculator to get this done. So the way we're going to do that is that we will enter the values from the contingency table into matrix A. So to access that, you'll go to second matrix, edit, and then enter the values. So you'll have to enter the size of the matrix. That will be the number of rows by the number of columns. Then you can enter the values into the table, and after that, quit out of that menu. Once you have that, then we can go and access the chi-squared test. So we'll go to stat and the test and the chi-squared test. Then it will ask you, and these will automatically populate, that the observed values will be in A. Yes, they are, because up here we just entered them at A. And it'll say the expected will be in B. Now notice this, you do not have to enter anything into the matrix B. The calculator is going to automatically calculate the expected values for us. However, if you do want to see what the expected values are, once we perform the test after it's done, you could go back into that matrix editor equation and edit B. And once you are in there to edit it, the values that were calculated will appear. So you have the observed. Once you go into the test, you'll get the observed, you'll get the expected, and then it'll ask you to calculate. So click calculate, and once you do that, you've executed the test, and the calculator will then tell us what the test statistic is, what our p-value is, and it will tell us the degrees of freedom.